Hello, everyone. It's a pleasure and an honor to have the opportunity to express some of our current work in the Superintendency of Banks and the way we tackle the important subject of cybersecurity program development. Please allow me to tell a little about myself. I have an electronics and communications engineering degree and a master in electronic commerce. I'm also the proud father of 3 beautiful children. My professional experience is diverse, covering industries like telecommunications, financial services, and online gaming, but also government and education. Lastly, I want to point out in my bio that I recently got a couple of certifications from MITRE's in January, named Attack Defender. I think it's worth to mention since our cybersecurity program is strongly influenced by Attack Framework. During this session, we'll try to cover 5 topics. Try to cover everything from the start to the beginning regarding the cybersecurity program. As the title of the session suggests, I'll try to define a working approach on developing a cybersecurity program, more specifically a data-driven cybersecurity program built around an open and data-centric platform as it is the Elastic Stack. My hope is that at the end of the presentation, you have a good idea of one of many possible practical approaches to develop a cybersecurity program with a focus in what is called today a threat-informed defense. Before we start, let's have a short introduction to establish some context from the presentation. When starting the journey of developing a cybersecurity program, we can be in a variety of situations. If you're in a compliance-oriented organizations like government, finance, and health sectors, you can be overwhelmed by the amount of regulations, norms, and controls that you need to take into consideration. Similarly, you can also be overwhelmed by the amount of chaos, bad things, and I have to say, enormous amount of marketing promises made by the cybersecurity industry. But you can also be in a situation where you have nothing, a big void with a lot of requirements and a lot of expectations from the executives to get a hold of cybersecurity. So how do we make sure we have a good start? Let's start with the basics. What are the main goals of a cybersecurity program? Some of the more frequent goals that you can find are reach customer and or citizens' expectations about a product or service, preserve the principles of any security infrastructure, like for confidentiality, integrity, and availability that everyone knows in cybersecurity, protect and secure people, process, and technologies, gain visibility into what's happening in IT infrastructure and business process. Most importantly, develop a data-driven cybersecurity approach. Another goal, of course, will be regulatory compliance. And finally, what everyone wants to achieve is to properly manage cyber risk. On the other hand, it might be useful to enumerate what should not be part of a program goals. First, promote a security theater culture, a show and tell approach that doesn't have a real impact on security posture. Second, outsource every process and security operations you can afford, as it happens usually in the financial sector where you have all the money available for making the investments. Third, create a negative security awareness culture through scare tactics. Never works. Keep a growing arsenal of security tools that usually ends into shelfware. Fancy dashboards and reports that favors a culture of everything is okay because our indicators are green. Although important, too much concentration on having a good project management can divert focus from solving the real issue. So you need to be sure that you don't do that. Once you're clear with the goals, it's a matter of starting with what is ideally a very simple process. Step 1, start with defining your current risk profile and exposure levels, always with initial goals in mind. Step 2, establish a cybersecurity program, that will be the engine that transforms the current risk profile. 2 things to make emphasis: deploy cyber hygiene practices and maintain high visibility of your information assets. In step 3, you reach a desired risk profile and establish proper program metrics to 1, communicate to the board, and 2, continuously enhance security operation. The idea is to establish some sort of controls factory or defense factory where you can transform your organizational risk profile in a positive way, of course. Moving to the next topic, let's see how we put that simple process into practice with an emphasis on data and visibility. Cybersecurity and risk-wise, your organization can be one of two types: the usual compliance-driven, or as defined more recently, a threat-driven. You can be one of those two types. No matter which one you are, you should structure your cybersecurity program around three pillars. First, visibility, where you select most important data sources and collect data from day one, just from the beginning. Grab all existing documentation, scan all networks continuously to maintain a dynamic inventory of endpoints and services. It's very important. Second pillar is the risk framework. Implement a cyber hygiene practices, be aware of your regulatory compliance challenges, and use a proper source of security controls and frameworks. The idea is to organize your security operations around resilience. And finally, threats. Implement a threat-informed defense practice in order to continuously validate your controls and establish proper metrics to track progress. Regarding visibility, you can start collecting a variety of data sources in a prioritized way. You can use excellent guidance from MITRE ATT&CK framework, but you can also find particularly useful this presentation I'm showing this slide from Elastic's which is Devon Kerr. The presentation is titled Threat Hunting for Visibility. Here, you can see one of the presentations I have used several times when talking about good data sources. Besides taking into account regulatory compliance requirements, and certainly we all have most of the time, you need to build your cybersecurity program around major and consensus-driven frameworks like the ones from CIS and NIST. This is important for establishing a common language when talking about cybersecurity posture with other industry peers. You want to establish some sort of benchmarking with other peers. Regarding cyber threat frameworks, there are several options as well, like Lockheed Martin Cyber Kill Chain, but we really favor and recommend MITRE ATT&CK. This is the perfect complement for a risk management practice, one that takes into account cyber threat intelligence and effective defensive measures. Since visibility is one of the pillars of our program, let's go to the next point in the agenda and talk briefly about these data sources, which are the ones making visibility possible. Data is the genesis of all cybersecurity programs, every one of them. Our main suggestion is to spend most of the time possible defining a strategy for collecting, maintaining, and visualizing data sources. You start collecting data even before the design of the cybersecurity program, at the very beginning. Any data, from documentation, diagrams, manuals, to continuous scanning of the different networks. Don't get caught spending too much time in defining the perfect plan for implementing your program. Build a strong data gathering operation. This is the most difficult part in most endeavors of cybersecurity programs. If you're like us and build your security using a platform like the one from Elastic, do not hesitate on collecting any type and amount of data. OS telemetry, networking and security equipment, application, internet services, etc. Prioritize your most important data sources in order to understand your risk and exposure. Use insights from this data to start proper cyber hygiene. That way, you'll get the opportunity of starting cybersecurity program without worrying about the low-hanging fruit of threats and vulnerabilities. Define effective metrics from your prioritized data sources. This will help later in the mapping process to regulations and frameworks. From the several approaches we can use to prioritize data sources, we tend to use information like the following slide from Threat Canary, from a presentation from Threat Canary titled Top 10 Data Sources. This slide shows the proportion of data sources of network and endpoint nature they use when providing their service. You may argue with the proportion, between network and endpoint, because Threat Canary is an endpoint-based product company, but frameworks like ATT&CK tend to be in line with this slide, with this proportion between network and endpoint data sources. This slide also shows data sources by prevalence, the top 10 data sources. Again, if you check the data source of prevalence in ATT&CK framework, you will find a strong similarities, which is a good thing. You can always start with this kind of data sources. We finally reached the topic that describes our practical approach for developing and establishing a cybersecurity program. You know, just the most important part of the presentation, I guess. Taking into account Schneider's code regarding complexity, we wanted to have a simple approach for building our cybersecurity program. So we just added 2 steps to the simple process shown earlier, and of course, we'd make it cyclical. First, collect all kinds of data in a prioritized way. Understand your attack surface, which is the most important things when you start. Create a current risk profile from collected data. Map your data to the selected cybersecurity framework, the one you will use. The goal here is to use a common language to measure your progress and exposure, like we said earlier. Start your cybersecurity hygiene practice and establish basic incident response capabilities. It is important to not wait for building a perfect program to handle the low-hanging fruits. Map your current risk profile to any applicable regulation. Define your desired risk profile and develop a plan to achieving it. Dealing with regulation at this step, make sure that we focus on the basic security capabilities and issues. It's very important. While implementing your plan, establish a threat-informed defense practice to continuously validate your controls against a prioritized list of techniques, tactics, and procedures. The goal is to balance your compliance-driven operations with the threat-driven practices, okay? Between risk and threat, having a good balance, which is the deal of cybersecurity. Let's dig a little more into every step, okay? So how we can handle the program. Well, you can see in this slide, we collect all data sources through either Elastic Agent, FileBit, MetricBit, etc., or Logstash for making SQL queries to databases. From there, we go to the usual Elastic workflow of discover, visualize, security analytics, alerts, dashboards, etc. This data help our SOC team and maintains a proper reporting of progress of our cybersecurity program. In order to understand your current risk profile, we use search queries and elastic security detections to understand coverage of the frameworks. As you can see, in our case, we use CSC, the Critical Security Controls, Community Defense Model, and MITRE ATT&CK. The idea here is that you are a search query away from knowing if you are you comply with the controls of risk framework. For establishing our basic incident management capabilities, we use Elastic Security Cases and Jira to keep a log of all issues or security-related issues. This is a great middle step before getting to more sophisticated SOC tools and platforms. As you can see from this following diagram, we map our regulation, which have 292 controls, to CIS critical security controls. We use a tool called CIS-CSAT to follow the progress of security controls and program implementation. Then we map the combined regulation to attack techniques. As mentioned before, the idea is to have a combined view of coverage of control, threats, and defenses. This final slide shows that for our implementation of threat-informed defense, we're currently using Operator from Prelude and Vector to continuously test our controls using adversarial emulation. The results of the different operator tests are fed into the Elastic workflow for reporting and help to make a proper attack SOC assessment, which is basically involves understanding our data sources, tools, and analytics coverage in order to finally deploy effective defenses. This in turn helps us to understand the real effectiveness of our controls. Okay, so we'll stop now and make sure I change to the demo part, the showcase part. Okay, for the showcase from the demo, I want to show you here a couple of things of how we progress into having a proper program, how to progress using Elastic in this case, okay? This first tab shows, like a CSC critical security control number 2 from the CIS framework, the security controls. And we can see here we have all the software installed. When you need to have an inventory of software assets. You can see how you see from my MacBook computer, we have all the software installed, operating system, all the specifications. So again, you can have all the data imported to Elastic and be ingested in Elastic and being able to show it in a search query, search for everything. The other thing you can do is to graph using the visualization library from Kibana and graph all your data, in this case from this critical security control 1, which maintains an inventory of controls. And you can see all the different hardware types you have in your organization. You can use either type of different types of visualizations in this case. You can use the same visualizations in time, for example, for this critical security contract number 8 of the DNS audit log, and see what kind of answers you get, DNS answers, queries you get from time in a time frame. Okay. If you have queries and visualizations, you of course can have also complete dashboard where you. This is the part when I mentioned that you can have a search queries of the dashboard where you have all the controls implemented and take a look and being able to visualize what each control is doing well, good or bad. For example, here I can show you CIS Control 1 inventory of uncontrolled enterprise assets. Okay, you can show you several of them. CIS Control 8 audit log and management, which has DNS queries output. CIS Control 10 malware defenses. We have a McAfee policy orchestrator data over here, so we can have our complete visibility how we're doing our malware defenses. CIS Control 13 network monitoring and defenses, and specifically, I can show you here network flows, which is safeguard 13.6, called network traffic and flow logs. Okay, and then you have 3.9, and you can have everything here on a dashboard, on several dashboards that shows how you are following, or you're making how you're doing with the different controls in mind. For for making sure that we have a good incident program or incident response progress, we use cases, of course, from Elastic, and then once we have the cases in Elastic, we export them to Jira, and in Jira we make a proper documentation of every incident we detect or every issue we detect. Okay. And the last part I wanted to show is, for example, this is a sample network with a Linux machine, a Mac OS machine, and a Windows machine, where we install the Elastic agent and we install the operator agent for for command and control to be able to execute adversary tests. Okay. We can see when we execute the adversary tests, we have several alerts triggering on the Elastic, and we can see all the details about what's happening on that alert. Okay, you can go to the query analyzer where you can see to the analyzer you can see all the details about what process are triggered and so on. But the thing that we use mostly, is we export the data from the adversary emulation, from the attacks. We use a tool, platform called Vector, and in Vector, hold on a second, let me just log in. And in Vector, we can visualize, we can export the data, the alerts that you just saw in Elastic cases and Elastic Alert, sorry, you can export to this environment, so you can visualize completely all the different stages of the attack. So from here, you can understand how the adversary issue the attack, what are the different tools, what are the different stages. If you click on one of the stages, you can see that you have the red team and blue team view, where you can document every aspect of what you did during your exercise. This is very important to be able to making sure that you have proper teaming practices and you are able to establish a threat-informed defense. So switching again to the last part, let's go again to the presentation. Let me share again. So I had a chance to show you a couple of things we do, and just to see the practical aspects of what we do. But let's go to the final part of showing you what are the lessons learned and what we have learned from from our time dealing with the Elastic and building our cybersecurity program. Okay, I'm following the steps and the approach and the methodology we just showed. First, defenders need to design simple cybersecurity programs. That's the very first. It sounds obvious, but this is very important. If you have a complex world, you have complex operations, your cybersecurity programs really need to be simple in order to follow up for your team and for the board and for the executive team to be able to follow what you're doing. It needs to be simple, need to be simple to manage. Simple cybersecurity program starts with good cyber hygiene. Okay. This is very important, and high quality data. Okay, high quality data. As I said earlier, data is everything in this cybersecurity program. So you need to take into account this important aspect. Operational aspect of collecting and maintaining data sources can be challenging. You know, this is similarly as a data scientist, you know, have a lot of challenges cleaning the data, obtaining the right data, and, you know, arranging that the data is a proper one for building a machine learning model. In cybersecurity analytics, is the same. You need to have a proper handle the data, you know, and it takes like around 60% of the time just to have enough data sources and handle enough good data sources to have your program. Elastic security operational workflows are a great way to understand how to operationalize cybersecurity programs. Okay. Visibility, as I said earlier, should be the starting point, an integral part of every strategy and cybersecurity program. Methodologies and tools associated with threat-informed defense provide a new set of capability and metrics. And again, you know, usually in our industry, IT risk is everything, you know, but you know, what we have learned from the threat intelligence, from threat-informed defense, and, you know, attack framework is that, you know, we need to have a balance between risk and threat, between risk, cyber risk and threat, and be able to understand our adversary to build effective cybersecurity program. Communicating how a good defense or counter works for a specific threat is a better approach than just communicating the availability of a specific contract. What I'm trying to say here is that, you know, it's much better to show to the organization that you have proper defenses in place, that at some amount, that is much better than you say that you have all the controls in a given framework, and you are fulfilling, you're making sure that all the controls are in place. Having the controls is good, but having the defenses, you just make sure that you test those controls are working or not. This is the end of the presentation. Thank you very much for paying attention. I hope this has been useful in some way, and I believe there is a chat box you can put questions, so welcome them. Thank you very much.